In this video, we're going to discover and go over all of the different types of the transformations of trig functions. There's two types, either dilation or translation. So translation is shifting left, right, up, down. Dilation is stretch or shrink. That can also happen vertical or horizontally as well. Keep in mind that stretching can also be known as expanding, and shrinking can also be known as compressing. I just want to quickly say that this is a snippet of my lesson. So if you want the full access with packet, with exercises, step-by-step answer keys, notes, reference sheets, all that fun stuff, either you can stay to the end, I'll talk more about that, or you can check in the description. I left a link to my website. So we're going to see through all the examples and discover how, for example, the a, or the leading coefficient, aka the number in the front of the sine or the cosine function, is going to determine your amplitude. So if you take that positive value or the absolute value of a, that tells you the amplitude, we're going to see that the value of a is going to influence the vertical stretch or shrink. We're also going to see how the value b affects the period. That formula is 2 pi over the positive number of whatever b is. And that b value is also going to determine what the horizontal stretch or shrink might be, if there are any. We're going to see how that value c affects the horizontal, also known as the phase shift. And that formula is you take that c value and divide it by b, and that determines if that value c is any number other than 0, that means it's going to be a shift left or right. And how many units? That's going to be, again, that c value divided by b. Last but not least, the d value is also going to be a shift. This one's going to be a vertical shift. So in other words, you're going to be shifting up or down d units, whatever value that d is. Now, d also has to do with the equation of the midline, y equals d. So let's take a look at our first example. We're going to be looking at the unit circle because I want us to actually figure out where it comes from. So the first one is going to be y equals 2 times sine of x. Now keep in mind what is different if we determine what a, b, c, or d is. We're looking down here. What's another way that we can write y equals 2 times sine of x? We can write it this way, right? It's going to be 2 times sine of x has the coefficient of 1. I can either add or subtract 0, but if we're just going to follow the formula, it would be minus 0 and then plus 0, right? That's the same thing. So that means that a is 2, b is 1, c is 0, and d is also 0. Now, in every parent function, y equals sine of x or y equals cosine of x, that b value is always going to be 1. And the a is 1 as well. So, and c is 0 and d is 0. So really the only thing that is different here, if we take notice, is that the a value has changed. It has gone up from 1 to 2. Let's actually use the unit circle to help us. Now, I'm not going to go over the unit circle. I'm just going to kind of do it those evaluations pretty fast. I'll leave a link in the description. I did a full video on evaluating trig functions. But if you notice, the function is going to be f of x or y equals 2 times sine of x. Now, let's say I do the x value is negative 2 pi, right? So I'm going to do sine of negative 2 pi. Well, negative 2 pi is coterminal with 0. So sine of 0 is 0. And then 2 times 0, so that's going to be 0. Now we're going to do, so first, where is negative 3 pi over 2? That value is coterminal with positive pi over 2, so that value is 1, and then 2 times 1 is 2. Now I'm not going to do all of these step by step. I'm going to just fast forward it, but feel free to pause the video and then try these out yourself. It's nice practice. So I'll see you in a second. Okay, so we did all of the evaluations, and then multiplied that answer by 2, because that's what the function is. So for example, if we are trying to sketch this function, this is when the x value was negative 2 pi. And so since that x value is negative 2 pi, that y value is 0, then that means this ordered pair is over here, negative 2 pi comma 0. If we look at when this x value is negative 3 pi over 2, that value was 2. So in other words, that point is going to be up here. So again, I'm going to click the fast forward button. And again, feel free if you want to hit the pause button and try it out yourself. I'll see you in a second. Okay, so I have plotted all of the points, and if we connect, we know that it's going to be a wave. So it's a little squiggly here, but we can see here are 2 periods of a sine function, and we know because here's one period, right? That's a sideways S. It first goes up to the maximum and then down to the minimum, and then we have another one. So what has changed? Well, if you remember, what if it was just y equals sine of x, right? So this is what we have to compare. This is the original parent function. What has changed? Well, we can see that, first of all, the amplitude of the orange or of the parent function, right? So the distance from the midline of both of these functions is the x-axis, or y equals 0. So we can see that the distance from the midline to the maximum, which is the distance from the midline to the minimum. So the amplitude of the orange function is 1, as opposed to the amplitude of the blue function, which is the transform function, is now going to be 2, right? That distance is going to be 2. So notice a couple of things. If the a value is a number other than 1, notice that the amplitude will match that same a value, right? So a was 2, so therefore the amplitude is 2. And another thing that we can identify is that is going to be a vertical stretch. Notice if I take it vertically, it's kind of, as I said, like a rubber band stretching it up. It got skinnier, if you will. Okay, so I'm going to, if you're welcome to hit the pause button and you can try this out. Otherwise, I'm just going to hit the fast forward button. I would highly recommend that you would try this out by yourself. And I'll talk about this in a couple of minutes. Okay, so we already talked about that the amplitude is now 2, and therefore the range, it goes from -1 to +1. Now it goes from -2 to +2, so it does absolutely affect the range as well. And so this, since it was stretched vertically, this is called a vertical stretch, also known as a vertical expansion. Now, what is the connection between the amplitude, the range, and the transformation? So think about a sentence that you can put together. The range intervals are the same number as the amplitude, and the amplitude determines the vertical stretch. Let's write that down. So let's take a look at, for example, so if we write this in another way, right? So this is the same thing as y equals 1/2 times sine of 1 times x minus 0 plus 0. So nothing has changed except the a value, except now the absolute value of a, or the amplitude, is going to be a number between 0 and 1. Notice 1/2 is between 0 and 1. And so now, since this is the function f of x of 1/2 times sine of each of the x values. So again, we're going to take a look at 2 periods between -2 pi and +2 pi. So I'm going to do a couple together. Maybe I'll do some of the positive x values, and then I'll fast forward it. Okay, so let's take a look at, these are all of the positive x values, and then I'll finish the other ones. So we're going to be doing the x value 0, right? So sine of 0, if we remember really quickly, here's 0 radians, so sine is always going to be the y value. So sine of 0 is 0, and then we're going to multiply that value times 1/2. Well, 1/2 times 0 is 0. Now, where is pi over 2? And we're going to do the sine of that value. So here's pi over 2. Again, because in every sine function on the unit circle, we look at the y value of the ordered pair. Sine of pi over 2 is 1. And so then what's 1/2 times 1 is going to be 1/2. Okay, so again, I will hit the fast forward button, but feel free to, it's good practice if you want to do this on your own. Okay, and so again, I'm going to plot a couple of points together, and then I'll hit the fast forward button. But let's say if we want to write that guy here as an ordered pair, notice the x value was negative 3 pi over 2. So when we input that value into the function, we got 1/2 as our y value. And so negative 3 pi over 2, 1/2, that is going to be right around here. Okay, so I'm going to hit the fast forward button, but feel free to try this out on your own. Okay, so here would be the graph 2 periods of y equals 1/2 times sine of x. And so let's take a look at if we just compare the parent function would be like this, right? Okay, so we can see it's kind of that green function, right? It started up with the amplitude as 1, and it was kind of smushed more kind of towards a pancake. It got shorter vertically, right? So we can see it's closer to the midline, to the x-axis. So again, I'm going to hit the pause button. Feel free to try this out on your own. Otherwise, I'm going to hit the fast forward button. Okay, so the amplitude is now 1/2 as opposed to 1. And so the range obviously went from -1 to 1 to -1/2, 1/2. And the amplitude, instead of getting bigger as the other example, now it got smaller. And so this all happened vertically. So this is called a vertical shrink, aka compression. So now what would be the connection between the amplitude, the range, and the transformation? While the range interval matches the amplitude, and the amplitude determines the vertical shrink. And I'm going to write that down in a second. So notice that the amplitude, or the absolute value of A, in other words, that positive value of A, that leading coefficient, which is the number in front of the trig function, that is going to directly determine whether there's going to be a vertical stretch or a shrink, assuming that number is not positive 1. So if we put it all together, the A value is going to help determine whether there's going to be a vertical stretch or a vertical shrink. Now remember that the A value is going to determine what the amplitude is, which is the absolute value of A, and it also affects the range, right? It's going to match that value. But particularly if that amplitude is bigger than 1, there is going to be a vertical stretch. And if that amplitude number is going to be between 0 and 1, essentially pretty much like a fraction, but if it's between 0 and 1, it's going to be a vertical shrink. And keep in mind, why are we comparing it to the value 1? Is because if we look at the parent functions, sine or cosine of x, right, the A value is going to be 1. And so that's why we have it to compare it to. So if the A value is a number that's not positive 1, or the amplitude is 1, then we can determine what the transformation is going to be. Now, keep in mind, why are we talking about only the positive A values, right? The absolute value means positive. It's because when you have a negative A value, like let's say if we have -1 times sine of x, all that means, just a reminder, is there's going to be a reflection over the midline. And so we are only interested in the positive value of A, or the absolute value of A, which is the amplitude. So we talked about the vertical transformation of dilation, right? Stretching or shrinking. The other type of vertical transformation is going to be translation or shifting. Now, vertical just means we're going to be shifting up or down, right? So we're going to see where the D value plays into all of this. So I'm just going to do the first couple together, and then you can, I'll fast forward the other ones. But if we take a look at the x value 0, well, sine of 0 is 0. And then if I add 2 to that, 0 plus 2 is 2. And so when x equals 0, y equals 2. So that ordered pair is right over here. Now, if we take a look at the x value pi over 2, sine of pi over 2 is 1. And so when I add 2 to that, 1 plus 2 is 3. And so that ordered pair is going to be pi over 2, comma, 3, which is right up here. Okay, so you can feel free to press pause and try it yourself, or I'm just going to hit the fast forward button. Okay, so this would be one period of this function here. Now, if we compare it to the parent function, it would look like this, right? It would be this blue function here. This is the parent function. And so we can see it has shifted, the entire function has shifted it up 2 units. It's like as if I would copy and paste it, but now it's higher up vertically. And so we can see here that what has changed in the equation. And so if we compare what happened to the a, b, c, d values of this function here, well, a is 1, so that didn't change. B is also 1, that didn't change. C is 0, so that didn't change. D is not 0 anymore, it's now 2. So we could see that the only thing that changed in this equation is the d value. It went from 0 to 2. Now, what is the midline of this graph? So I'm going to erase the parent function here. So the midline of the parent function, remember, was the x-axis, or y equals 0. So now what is the middle line or midline that cuts this graph if we look at the y values? What are the middle y values, if we will? And we can see that it's going to be this horizontal line, y equals 2. Do you notice anything between the d value and the midline equation? Yes, those are the same values. Now I'll press pause, try to answer these questions, or I'm going to hit the fast forward button and we'll talk about it. Okay, so we just saw that if d equals 2, then the midline equation is going to be that value of d. And so the midline equation is going to be y equals d, because they are the same number. Now there's a few things going on. If we compare to the sine parent function, y equals sine of x, how is both the graph and the equation different if we were to compare it to y equals sine of x, so that parent function, and now I take that entire function and add 2. So what's going on? Well, there's a few things, right? So we already talked about this one here. The d value went from 0 to 2. And so that is going to change. The midline is going to be from y equals 0, aka the x-axis, to y equals 2. Now, the other things that happen is the range. If you remember from geometry class where you did talk about translation, what you do is you can add 2 to both of the n values. In other words, -1 plus 2 is +1. And +1 plus 2 is going to be 3. And that's where that comes from. So the range is also different. And last but not least, most importantly of all, we can see that it's going to be a vertical shift. It's shifted up 2 units. Now, here's the really important thing, because people confuse between the horizontal shift and the vertical shift. So what do you notice about the sign in the equation, right? If we talk about y equals sine of x plus 2. So in the equation, we have this sign, which is plus, right? How do we compare that to the direction of the transformation? Well, notice that since it was a plus sign, that plus directly translated to the function moving up. And so it is the same direction as if what we'd naturally think. In other words, we can already assume that if it was minus, naturally we think, okay, then that's down. So I just wanted to point that out, because when we do the horizontal shifts, it's going to be the opposite. So in other words, plus actually means to the left and minus actually means to the right. So that's why I wanted to point this out. And just a reminder, right, this is called a vertical shift. Last of the vertical transformations, what happens if the d value is a -2 instead of a +2, like the last example? So a is 1, b is 1, c is 0, and d is a -2. So we have here the 5 main values. And now if we plug it into the function, we're going to do sine of that value and then -2. So we know that sine of 0 is 0, and then 0 minus 2 gives us a -2. And sine of pi over 2 is going to give us 1 if we subtract 2 from there. So that way this value is -1. Sine of pi, we'll do one more, and then I'll fast forward and plot those points. Sine of pi is 0, and then 0 minus 2. So we're back at -2. So I'm going to hit the fast forward button. I'm going to finish the other two evaluations, and then I'm going to plot those points. Okay, so I plotted those 5 main x values into the function. We do have a 1 period of a sine wave because it's like that sideways S. So now in this case, it appears that it has shifted down 2 units. And instead of the midline, which was the x-axis for the parent function, notice the midline is now y equals -2. So the midline did shift down 2 units. We could see that. Right, so that would be the equation of the midline. So that would be the answer to this question, right? What is the midline equation? It's the horizontal line, y equals -2. Notice right off the bat, same as in the previous example, the d value is going to match the value in the midline equation. And I'm going to ask if you want to press pause and answer these questions, or I'll hit the fast forward button and we'll talk about the answers. Okay, so what is the connection between the d value and the midline equation? We talked about they are going to be the same value or the same number. And there is a general equation. So the general equation for the midline is y equals and then whatever the d value is. So y equals -2, that does definitely confirm. So there are 4 main things compared to the parent function y equals sine of x. The graph and the equation are different in 4 of the following ways. We saw graphically that it's going to shift down 2 units, and we saw that d equals 0, changing from d equals -2 is also going to change, right? The midline is now y equals 0 to y equals -2, so those values are consistent. Last but not least, the range is between -1 and 1. That was the parent function. Now it is between -3 and -1 that we can see from the graph. And similarly, and from geometry class, when you learn translation, you could take the two n values. So a -1 minus 2 gives us a -3, and then +1, that other n value, if we subtract 2, we also do get a -1. So everything definitely checks out. So similar important note like the previous example, what's the correlation between the sign of the equation? So again, the equation was y equals sine of x -2. So I'm talking about this subtraction sign here. How do we compare that to the direction of the transformation? So remember, we went down 2 units. So that would imply, right, that the minus sign correlates to moving down. And so that's the same direction as we'd naturally think. So later when we do the horizontal transformation, it's going to be the opposite of what we think. So we'll talk about that a little later, but let me write this down. Right, so if the d value is plus, we go up. If the d value is minus, we go down. So it makes sense in our heads that that would be the case. And so last but not least, this is a vertical shift, as we've been talking about. In this case, we'd be moving down. Okay, so far we looked at the vertical transformation, shifting up or down, as well as a vertical stretch or shrink, or expansion or compression. Now let's take a look at the horizontal transformation. So that is going to be stretch or shrink horizontally, as well as shifting left or right horizontally as well. So if we take a look at this example here, y equals sine of, and inside the parentheses is x plus pi over 2. What is, as we've seen, this is a graph here, what is the comparison to the parent sine function? Well, the parent sine function would look like this, right? And so how would we compare it to the graph that we see here? So naturally, because we see a plus sign here, we want to go to the right. But it turns out that, as we can see from the graph, it actually moved to the left pi over 2 units. So instead of starting at 0 for the period, it now starts at -pi over 2. And we can rewrite. So remember that in general, it's really going to be a minus c here, right? As with the formula that you have used. So since it's a plus here, I could actually write this as x minus a -2 inside the parentheses, right? Because a minus and a minus is a plus. So when we define a, b, c, d, c is actually technically going to be -π/2, right? A is 1, B is 1, C is -π/2, and the D value is 0. So it turns out here that the phase shift or the horizontal shift, which we'll talk about that vocab word, the horizontal or the phase shift is actually going to be your starting value for when we're going to be graphing the transformations. So that's my future video. I'll write a link, I'll leave a link into the description if you want to look at that video. But as of right now, I'm just pointing that out, that the phase shift or the horizontal shift is going to be the starting value for when we graph. And so what if we were to identify the period, right? So if we look at the purple graph here, the period was 2 pi. It does complete one full cycle, like a sideways S, in 2 pi radians. Now, is this still the case, right? So as we could see, it is one period. So what is the distance from here to here, right? Because that would be the period. How long does it take for it to complete that sideways S cycle? So we are on a number line here. So how do we find the distance between 2 points? You can actually subtract the n values. And since we are talking about the distance, we can actually, it's technically supposed to be the absolute value. So if I just subtract -π/2 and 3π/2, and I do want to do the absolute value again because distance is positive. So -π/2 minus 3π/2 is -4π/2. -4 divided by 2, so that would just be -2 pi. And the absolute value of 2 pi is 2 pi. So it just means it makes it positive. So the period is the same as the parent function. That has not changed. So I'm going to press pause. If you want to answer this question, feel free to look at the graph. Otherwise, I'm just going to fast forward it and then we'll talk about it. Okay, so it shifted to the left pi/2 units. We talked about the start point is -π/2, 0 instead of 0, 0 in the parent function. The c value is -π/2. Notice it's the same starting value as the x value, right? So this guy here is our c value. Okay, so this transformation is called a horizontal shift, but honestly, more often than not, you're going to be asked the fancier term, which is a phase shift. So phase shift and horizontal shift is the same thing, right? It means shifting to the left and to the right. So the sign of in the equation, remember it was y equals sine of x plus pi/2. So we can see that this plus sign here in relation to the direction of the transformation. So it's technically like the opposite of what we'd naturally think, right? So plus actually means to the left. So naturally we want to say it goes to the right, but unfortunately it doesn't work that way. So I'm going to write its opposite direction of what we'd naturally think. And the general formula for the horizontal or the phase shift is the c value divided by the b value. So in this case, it's definitely true, right? Because we could see that the c value, which was -π/2, and the b value, which was 1. So -π/2 divided by 1 is -π/2. So it does check out. Okay, so what if instead of a plus, now it's a minus? So this is the parent function. So really quickly, we can see that it actually shifted now to the right. Okay, so it's going to be, again, minus means to the right, and plus means to the left. Okay, so A is 1, B is 1, C is now +π/2. and the d value is 0. So again, that's the only thing that changes. And it turns out that the period is still going to be 2 pi. Right? So if we look on the graph, what is the distance between here and here, right? How long does it take for it to complete one big cycle? So again, on the number line, you can just subtract the two values and the absolute value because distance is positive. So that's going to be negative 4 pi over 2, which is equal to negative 2 pi. So the distance is still going to be 2 pi. So that doesn't change. And it turns out, we'll see later, that when the b value, when that's the one that changes, so when it's not 1, that's what's going to affect the period. So that's more later. So how is both the equation and the graph different? So you can press pause, or I'm going to hit the fast forward button and we'll talk about that. Okay, so we can see that it does shift to the right pi over 2 units. The starting point is pi over 2, 0 instead of 0, 0. And that c value, pi over 2, happens to be the start value. So again, it turns out that the phase shift, so that formula we talked about over here, that is going to be your starting value for when we do graphing. So again, I'll leave a link in the description. So this, as we said before, I'll abbreviate here. This could be a horizontal shift, which can also be called a phase shift. And the sign here was a minus, and that means we went to the right. And so again, it's going to be the opposite direction of what we would naturally think. Okay, and so the general formula for the phase shift, which we talked about before, so here it is again, it's the c value divided by the b value. And so the c value was positive pi over 2, the b value was 1, pi over 2 divided by 1 does give us the correct starting value, which again, we'll see when we graph. So we saw what happens when the a value changes, when the d value changes. We just did when the c value changes. Last but not least, what happens to the graph if the b value is different than the parent function? So the parent function, the b value is 1. So what happens when it is not 1? So in this particular case, the b value is going to be 2, right? So here's the graph y, or the equation y equals sine of 2x. So a is 1. B, as I said, is the only one that changes because C and D are 0. So that's the same as the parent function. Okay, so I have a table of values here. First, we have to figure out what happens when you double the x value. So I have over here in this column, and then we're finding sine of whatever that double x value is. So we're going to put that final y value of the ordered pair in there. So we'll do the first couple together, and then you can press pause and try it out, and I'll fast forward. But I already had x values planned for you here. So what happens when you have 0, pi over 4, pi over 2, 3 pi over 4, and pi? So I did have that on our graph. So first we're going to double it because that's what's in the equation. So 0 times 2 is 0. Pi over 4 times 2 is going to be, right, so times 2 over 1. So that's going to be 2 pi over 4. So that's going to be pi over 2. Okay, so if we just do the first of them together, so now we have to do what is sine of 0. Well, sine of 0 is going to be 0. And what is sine of pi over 2? That is 1. And so graphically, this ordered pair, right, this is the x value and this is the y value. So that's going to be 0, 0, which is here. And then another ordered pair is when x is pi over 4, y equals 1. So that's pi over 4 comma 1. So that's going to be that point over there. Okay, so again, I'm going to hit the fast forward button and feel free to try them all yourself. Okay, so obviously I strategically used those x values because I knew in advance it was going to produce one full period of this sine function here, y equals sine of 2x. Okay, so what is the period? In other words, what is the distance that it does complete that sideways S shape? So in other words, what's the distance from here to here? It completes one full cycle in pi radians, right? So the period instead of 2 pi is pi. And again, how do we know that it is in fact one period? Because it does have that sideways S shape. Okay, so in other words, as I said, it completes one cycle in pi units. So notice right off the bat that when the b value is not 1, it's going to affect the period of the function. So we can see that instead of 2 pi radians, now it's in half of the time. So there is going to be a horizontal compression or a shrink. Okay, so comparing to the parent function, how is both the graph and equation different? So I'm just going to write whatever I said down. Okay, and so the b value was 1 in the parent function, and now it is 2. So I did say before, what happens anytime you change the b value? So when b is not equal to 1, that affects the period. It is no longer 2 pi. Now, as I said before, since it happens in half the time, this is a horizontal shrink or a horizontal compression. So I'm abbreviating here, horizontal shrink, or as I said before, you can call it a compression. Okay, so now since the b value is 2, that is going to be in this category, right? So 2 is bigger than 1. So we found out that when the b value is going to be bigger than 1, there is going to be a horizontal compression or a horizontal shrink. So we are going to see that when that number is between 0 and 1, that it's going to be a stretch. Now, take note that the b value here is under the absolute value symbol, and that just means that the b value has to be positive. So if, for example, I had something like this, what if it was sine of negative 2x? I'm just talking about the actual number of the b. Yes, I know here b would be negative 2, but if we remember from transformations of polynomials, that negative sign would just mean there's a reflection, in this case over the y-axis, but that being said, that's what we're talking about here. So we're just talking about the actual numerical part of b. Okay, so last but not least, what if we had y equals, now instead of b equals 2, it's going to be 1/2, right? Because I can rewrite x over 2 is the same thing as 1/2 x. So now b is 1/2 x. And let me just write this down over here, that a is 1, b, as I said before, is now 1/2, c is still 0, and d is still 0. So everything else is the same as the parent function. Instead, now b is 1/2. Notice I did pick a number between 0 and 1. So in order to plot points, I did strategically use those x values here because I know it was going to complete in one full period. But in order to use the equation, first we have to cut that x angle in half, and then finally do sine of that x value. Okay, so again, I'll do the first couple together, and then I'll hit the fast forward button. So 0 times 1/2 is 0, and then sine of 0 is going to be 0. If we look over here, half of pi, or pi divided by 2, is going to be obviously pi divided by 2, and sine of pi over 2 is going to be 1. Okay, so try the rest out. Okay, so take note that this is going to be the x value, and this is going to be the y value. So 0, 0 is here, pi, 1 is here, 2 pi 0, 3 pi -1, and then 4 pi 0, right? So we do see that it does complete one full cycle here. So how do we know, again, that this is the period? Because it completes that sideways S looking shape. So the period, again, is the distance between, is the distance that it takes to travel in one full cycle. So what is the distance here? It is clearly 4 pi. So that's going to be the period, and I'm not going to write this down, but obviously we know that it's a period, as I said, because it completes one full cycle, that sideways S shape. So comparing to this, the sine function, how are both the graph and the equation different? So I said it out loud, so I'm just going to copy everything down. Okay, so it completes one full cycle in double the time. So instead of the period being 2 pi, now it has stretched horizontally. In other words, actually, it has completely doubled. So it went from b equals 1 in the parent function to b equals a half. And notice again that this is going to be a horizontal stretch. Okay, as I said before, b is not equal to 1, and so the period is no longer 2 pi. And last but not least, the general formula for the period, you might have learned this already, is 2 pi divided by that positive b value, so the absolute value of b. So we can clearly see that the b value does affect the period. So if I go back up here on this, this general form, right, remember 1/2 is a number between 0 and 1. So that means it is going to be a a horizontal stretch or expansion. Okay, so this is everything you need to know about transformations. Notice this could be a sine or a cosine function. In this lesson, I did just pick on the sine function, but it would be the same thing for cosine, that whenever you change the a value, so whenever it's not 1, that does change the amplitude, which is the positive value of a, right? Because it's the distance, and distance is always positive. So the a value is going to affect whether it's going to be a vertical stretch or shrink, again, if it's a number not equal to 1. We just talked about that if b is different than 1, then it's going to be a horizontal stretch or shrink. And that's because the b value is in the period formula. So that does make sense. The c value is going to be in the formula of the horizontal or the phase shift. So it's going to determine whether it's going to shift left or right. And the d value is going to be, if it's a number other than 0, it is going to shift d units up or down. And at the same time, it's also in the midline formula. So whatever the d value is going to be the equation of the midline as well. So I hope you have a clearer understanding on all the different types of transformation of trig functions. So in the description, I did leave a link to my website. You can download the packet that we just went through. I have full reference sheets, full homework assignments, and step-by-step answer keys, guided notes, all that fun stuff. So I really hope that if you're a student or a teacher, you would be able to find a lot more ease in learning this stuff. Make sure you hit that subscribe button so you don't miss out on future videos. And in the comments below, you can ask me a question if you were confused about anything, or if you have any other suggestions on other future videos that you want me to create.